Hey guys, and welcome to this new video. This video is part 2 of energy saving in a smart home during winter. This time it will get a bit more technical, as you can already see here. But before it gets too complicated, let's start off very simply with the intro. Have fun! Yes, and this video is a continuation of part 1. If you haven't seen it, just check out last week's video. In this part, we will discuss a really effective method to elevate the heating to a new energy level. A conventional heating system works on a relatively simple principle. The radiators get warm, the air around them heats up, slowly circulates in the room, and as a result, the room is effectively warmed up. The only problem with this situation is that air takes a relatively long time to circulate. So, by the time it is warmed up enough to start moving and the entire room is set in motion, it can take quite a while. Therefore, at the beginning, the heating is relatively ineffective. You can make the heating significantly more effective by moving the air yourself. And what option could you use to move the air? Of course, with a fan. This is a conventional PC fan, and it has the advantage of being by far the cheapest among the fans I was looking for, and it is even sold in a pack of 5. For this reason, I ordered a lot of these fans and developed the plan to equip each heating system here with such a fan. Now, I could simply let the fan run all the time. However, that would A. be a waste of electricity, B. be extremely cumbersome to turn them on and off all the time, and C. these fans are of course relatively loud when they are running at 100%. And accordingly, I thought it would be much better to attach several fans to a heating system and then run them at a lower speed. Ideally, I can also adjust the speed so that when I'm not in the room, for example, to be able to run the fan faster at times, or when I am sleeping in the same room to be able to run the fans even slower. Probably very few of you have dealt with fans, so I will give you a very brief explanation about PC fans. There are basically 2 types of fans. These are the 3-pole fans and the 4-pole fans. This here is a slightly larger 4-pole fan, and they only differ in this one pin. The 3-pole fan has a positive, negative, and a reading pin. This means that the fan operates at the usual 12V and runs at 100% performance when it receives the 12V. Through the 3rd pin, I can read this speed, meaning I can find out how fast the fan is actually spinning in this S. With a 4-pin fan, I have these 3 pins, as well as a 4th pin, through which I can specify how fast the fan should rotate. This means that 12V continuously flows through the 2 plus and minus pins. I can read the entire system through the 3rd pin, and through the 4th pin, I can control how fast this fan should rotate. So these are actually the best fans for my needs, because they are relatively easy to control and would give me the option to adjust the speed of this fan. The disadvantage of these 4-pole fans, however, is that they are significantly more expensive compared to the ones here, as I now need clearly more than 1 fan. To be precise, if I use 4 fans per heating unit, that makes a total of 20 fans, which results in a huge price difference. Accordingly, I quickly discarded the plan for the 4-pole fans and focused on these 3-pole fans instead. Here too, there is the possibility to adjust the speed variably. However, this is a bit more complicated, as we need to limit the positive and negative pins in the power supply. If we give the fan a little less power, it will also run slower. And if we can adjust this variably, then we actually have exactly what I wanted in the end. To variably output electricity, a small microcontroller is actually quite suitable. I have already introduced ESPHome in some other videos, the project that allows you to set up a Raspberry Pi very easily so that you can control it later through Home Assistant. In connection with this project, it would be relatively easy to implement such a fan control system. However, there is also a disadvantage, namely that this microcontroller can only handle 0 to 3, respectively. 5 volts to control. However, these fans here are 12 volts and probably require 2001, especially if I were to connect 4 of them to the microcontroller, which is a bit more than this port here can provide. Accordingly, I need a way to dynamically adjust a 12V fan with a 0 to 3V pin. And for this purpose, this so-called MOSFET is suitable, with which it is possible to control this 12V pin. Done and done. So, I connected these things together, and lo and behold, I can adjust the fan variably. All I need to do now is either take a 12V power supply and step it down to 5V to operate the microcontroller, or take a 5V power supply and step it up to 12V so that I can control the fan in addition to the microcontroller. So, I ordered another step-up module, and when you assemble it, you have a fan control for the heating. Now, of course, everything needs to be mounted on the heating system, and it would also be nice if the cables were somewhat organized. Accordingly, I have built a small box into which all these parts can be installed. In the end, there are magnets on the side, which keeps everything under the heating for me. Lastly, of course, the fan also needs to be considered. The fans are to be attached under the heating. For this, I have printed a small bracket here. The fan is screwed in from below, and two magnets are placed on top, which holds everything in place under the heating. All that is left now is to integrate this control into Home Assistant, because I want the fan to turn on when the heating starts and to turn off when the heating stops. Now, one could of course use a temperature sensor and somehow calculate whether the heating has turned on or if it has turned off again. But I thought I would save myself the whole thing and make it a bit easier since I already have a smart heating thermostat. That means I already know A, the room temperature, and B, whether the heating is currently heating this radiator. So I just had to create a simple automation that waits for 4 triggers. Either the heating in the office switches to heating mode or to preheating. That means the heating basically starts to heat the radiator here, or the heating switches from preheating to some other status for 10 minutes. From the heating operation to any from which I can assume, as you can already see from the ID names here, that the heating will turn off again. Up there with the 2, the heating turns on. I set it to 10 minutes so that the heating has a certain cooling time. In an optimal scenario, when it is still heating, it is relatively warm. This means that the fan can continue to keep the air in motion for a while. As an action, I have selected 2 options here. Either heating 1 or 2 is triggered, which means the heating turns on. In the case of USEND, I set the fan to a speed of 30%, so it doesn't run completely at full speed. When the automation is triggered, I also turn off the fan. And that's basically it with this very simple automation, in my opinion. I will include all the parts for those who are interested in building it themselves in the video description below. Please pay attention to the MOSFETs, as there are indeed very many to choose from, and I know that they will definitely work. Otherwise, that's it for this video. I hope you enjoyed it. If so, I would really appreciate a rating. If you don't want to miss anything, click subscribe, and I would say see you in the next video. Until then, take care and goodbye.